So 3.4 is talking about direct variation. So that's what we're going to do. We're going to talk about what direct variation is, and we're going to graph direct variation equations. Okay, so direct variation looks like y equals kx, but k cannot be 0. Okay, so it's not going to be y equals 0. Right? Now this looks a lot like our slope-intercept form, if you guys have seen slope-intercept before, okay, where the y-intercept is 0. That's really all it is. The one thing about this, we already know what y and x are. The one thing we don't know is what k is. Well, k is the constant of variation. Okay, the constant of variation is just the rate of change, which we know is also the same as the slope from last section. Okay, now the graph of a direct variation equation, because the y-intercept is 0, it's always going to pass through a specific point, and that point is the origin. Okay, so the origin, remember, is the middle point, the point 0, 0 of a graph. Okay, so this is just point 0, 0 on the graph. It's always going to go through that. Okay, all we have to figure out for a direct variation equation is the slope, or the constant of variation, or the rate of change. So what we're going to do to start is we're going to name the constant of variation, or the slope. Constant of variation is the same as the slope, right? And find the slope of the line to pass through each pair of points. So what we need to do here is just read the graph. So if you just pick any 2 points, you could pick the 2 points that are labeled for us here. All we gotta do is count the rise, count the run, and see what we've got, reduce our fraction. So if you count the rise, you're going up from 4, you count up here, you're going to go up 8 to get to 12, so that's plus 8, and you're going to go to the right, 1, 2, 3, 4, so you're going to go plus 4 to the right. Okay, so our slope, remember, is rise over run. So k equals 8 over 4, which we know reduces to k equals 2. Now the second one, you got to pick any 2 points. You can pick any 2 points you want. The easiest one is use the origin for these direct variation equations. The origin is always an option. Okay, so use it as much as you can. Now you count the rise and the run. You're going to go up 1 there, and you're going to go to the right 4. Okay, so our slope, which is k, or the constant of variation in this case, is rise over run, or 1 over 4. Now we're going to graph. Okay. Now the easiest thing about these graphs are that you know one point already. Your first point is always going to be, just for direct variation, 0, 0, the origin. You're always going to use 0, 0, the origin. Okay, and all you have to do is move with the slope. So to do negative 3 over 2, there's actually 2 ways to do that. It could either be negative 3 over positive 2, or it could be positive 3 over negative 2. Right, what positive 3 over negative 2 means is you're going to go up 3, and you're going to go left 2. Negative 3 over positive 2 means you're going to go down 3, right, because the top is up and down, and to the right 2. Okay, so let's do the down 3, right 2 first. Down 3, right 2 from our 0, 0. That's good. You could also go left 2 and up 3, which is great. Notice that that creates the exact same line either way. Okay, so you don't have to put both those points. You only need one of them. I'm just showing you have 2 different options to work it out, and then you connect the lines. For y equals 6x, right, we've got 6 is the same, of course, as 6 over 1. Okay, so there's 2 options again to do this. You could have positive 6 over positive 1, or negative 6 over negative 1, right? You cannot have just one negative. Okay, but remember, a negative over a negative is the same as a positive. So 2 ways that you can make this slope happen. You could go up 6 and right 1, or down 6 and left 1, that equal sign. Okay, so if we go up 6 and right 1, it'll leave us there. And if you go down 6, left 1, it'll leave us there. Once again, it creates the same exact line. It's the same slope. Oops. So when you connect the dots, it looks something like that, but hopefully it'll be better on your side. Alright, so a couple more examples. First here, suppose y varies directly as x. What that means, y varies directly as x. This means that y equals kx. Alright, that means that we have a direct variation equation. Okay? Suppose y varies directly as x and y equals 9 when x equals 3. Okay, so that's giving us a y and an x, which we could just plug into our equation. So what we're going to do is we've got y equals kx. We know that y equals 9 and x equals negative 3. Okay, we want to find what k is. So to get k by itself here, we need to divide both sides by negative 3, because right now it's multiplying by negative 3. Those cancel out, and k equals negative 3, because 9 divided by negative 3 is negative 3. Okay, so k equals negative 3. We want to write the actual equation. So the actual equation here is y equals negative 3x. So that's the equation that we're talking about when y varies directly as x. So we're going to use our answer here in B to find x when y equals 15. So once again, we're going to plug in 15 for y. We're going to start with our equation, y equals negative 3x. I'm going to plug in 15 for y. And find what x is by dividing by negative 3. So we get x equals negative 5. Last problem here. A little bit of a word problem. We've got the Ramirez family is driving cross-country on vacation. They drive 330 miles in 5.5 hours. We're going to write a direct variation equation to find the distance driven in t time. Okay, so remember, we have a direct variation equation. They tell us that, which tells us that we've got y equals kx, right? But we're not going to use y and x. We're going to use d and t, because we've got distance and time. Okay? So we're going to plug in what we know. We know that 330 is the distance. We don't know what the constant of variation or the rate of change is, but we do know the time that they spent, which was 5.5. So that's what we plug in for time. Okay, so we divide both sides by 5.5. And we get something. Oh yeah, 60. So 330 divided by 5.5 is 60. Okay? So what that means is they're driving 60 miles per hour. Right? And our equation is going to be y equals 60. Oh, not y. We're not using y, we're using d. d equals 60t. Okay? Now to graph this, we got to draw the graph. Okay, so we'll draw the graph. I'm going to draw the graph like this because we don't care about the negative part of it. We just care really about the positive part of it. Okay, we need to label what we know, what this is talking about. So the d axis is going to be our y. The t axis is going to be our x. Okay, so because t is like in the x position and d is in the y position. So this means over here, this is the distance in miles. And this is going to be the time in hours. Okay? So for this one, we've got, let's just put 1, 2, 3, 4, 5. Okay? It gets us up to 5. Alright, we're counting by ones. And the second one, let's count by like 50s. 50, 100, 150, 200, 250, 300, 350. Okay? I'll just put some of the numbers in here so we know what we're counting from. Okay? Now, to graph this, we know that 330 and 5.5 is one of the things on here. We also know it's going to be going through 0. Right? 0, 0. Okay? So what we know we're doing is we're going up 60. So I need to go up 60, which is just above 50, right? And over 1. Okay? Up another 60, over 1. Up another 60, and over 1. And we see what our graph kind of looks like. Just like that. Okay? That's what our graph will look like. You could extend it the other way also. And we're going to estimate how many hours it would take to drive 500 miles. So we're going to go back to our equation for this. D equals 60t. Okay? I give you 500 miles. So am I going to plug that in for distance or am I going to plug it in for time? I don't know why I'm asking that. I'm talking to myself. But that's obviously a distance, right? Miles is a distance, not a time. So I'm going to plug that in for D. So I've got 500 equals 60t. Then I can do some division. right? Divide both sides by 60 to get t by itself, because we're trying to find the time. And we get t equals 8.3 hours. So it's take about 8 1/3 hours, which is about 8 hours and 20 minutes. That's it.